Hello everyone, in this tutorial we will create the sound system for our vehicle. We have the engine sound and the sound is depend on the speed, and when we hit another car we have the impact sound with the car and the glass that break. First, we open the last project and go to plugin. Search for MetaSound. MetaSound is a high-performance audio system that enables sound designer to have complete control over audio DSP generation of sound sources. Let's enable this. And search for MotoSynth. This is the vehicle engine sound. Enable and restart now. Go to City Sample Project and go to Audio, Vehicle. Click on this BP Audio Vehicle Collision Sound component. Right click. Choose Asset Action and Migrate. And disable this. We migrate only the game. And disable all of this. We only migrate this audio and click OK. Choose Destructible vehicle content and select folder. And we can close this. Now you can see this audio inside our project. Go to Audio, right click, Add folder, name it Struct, and open this Struct, and then we go to Blueprint and Structure. Name this Struct is ST Driving State, and open this Struct. The first member is throttle, and set it to float. Add variable, name it brake, and it is float. Add variable, name it steering. Add variable, B and brake on. And set it to boolean. Add variable, forward speed, and add variable RPM. Set the forward speed to float, RPM to float. Add variable, name is gear. The gear is float. Add variable, be automatic. set it to Boolean. A variable be all wheels on ground. A variable be no wheel on ground. We use data to know that which sound that we should play for our engine of the vehicle. Then add another structure. The struct name is st wheel suspension state. Open a variable. The first is previous normalize suspension length, and the second variable is time spent at full length, and set both of the variable to float. Then save all. Open vehicle folder and open BP audio vehicle collision sound component. And we have some error. Click on this, return to value, and we don't have this get city sample player character. Let's close all of these functions first. Get player character and connect it to get actor location. Compile, and this one get player character. And cast to actor. It is not the error, so no need to change. But this we don't have BPV call, so delete this and connect the cast file to this cast to static mesh actor. Compile. Go to event graph, and now this audio vehicle collision sound component is working correctly. To vehicle and blueprint, vehicle-based destruction, and in the event graph, add component, search for BP audio vehicle collision. This component will play the collision of the vehicle sound. And go back to BP audio vehicle collision. Open this sound selection. And you can see this sound selection. This is the sound, MetaSound, and when we play, you can hear it. Good sound deformation. This is the deformation sound and debris. and this wall impact large. It's really loud, this sound. So you need to have the MetaSound plugin. If you don't enable it before you migrate, you will don't have this sound that's set to the spawn sound attached node. Let's play test. Go to the vehicle and hit another vehicle. It don't have any sound. It's not play the collision sound because we don't have any event that call the sound to play and to show the hit location of that vehicle. So go to city sample project, open this vehicle blueprint, BP vehicle based destruction. Go to event graph and copy this audio. All of this audio event, copy and go to vehicle based destruction on our project and paste it here. And promote the dissolving to variable. And we compile. And we have this custom event because this on component hit event, we have one of it. So this one, we can call it again. Let's move this down. Press Ctrl, then reroute this node. Reroute this. Recombine struct pin. And this hit, we break result. And connect this hit bolt name and bolt name. And this hit, we create break hit result here. And connect this location, impact normal, and bolt name. Delete this. And we reroute node of the normal impulse. Connect it here. And add the actor. We get this on component hit adder actor. And from this, we create a sequence and connect it to this print string. And we can delete this custom event. You can move this up here and move this node here. And compile, save all. and close this. Let's play test and go inside this vehicle. When we collide with other vehicle, it plays the impact sound. Next, to create the engine sound system, we need to go to the audio, vehicle, and open this BP vehicle audio controller. Close this function. Open event graph. And go to vehicle, blueprint, BP vehicle base. Add child actor. And name this child actor is audio controller. On the event process, get audio controller and set child actor class. And the class is BP vehicle audio controller. And when we unprocess the vehicle, get audio controller and set child actor class and set it to empty, because when we get out of the vehicle, we don't want the sound of the vehicle engine. Next, we have to create some variable. Add variable. First is rear wheel flip angle drifting min threshold. And variable type is float. And add variable. Name is drifting with min threshold. And category is drifting. And this one is drifting, because we want to have the sound of the drift wheel of the vehicle. Compile. And this rear wheel slip angle is 10. Drifting with min threshold is 100. Then add variable. B is drifting. Set it to Boolean. The B in front of is drifting is Boolean. And set the category to drifting. Add variable. Name is driving state. And set the variable to st driving state structure. Add another variable. Name is wheel suspension state. And variable name is st wheel suspension state. And we compile. And for the wheel suspension state, set the variable to array. Compile again. Add array element. Add 4 array element because we have 4 wheels. Then add variable. The variable name is normalize suspension depth threshold. Variable type is float and single. Add variable name is B is possessed by player. Variable type boolean. Add variable B is hack. Add variable B is literally breaking. And add variable B is reversing. And B is okay to fire airborne event. And B automatic. Compile. For the normalized suspension, we set it to 0.1. After we set our actor class, we set is possessed by player to true, and for the unpossessed, we set it to false. And we need some of the event dispatcher to fire the event to the vehicle audio controller blueprint. We use event dispatcher because it does not require the actor reference, and we can bind the event and it's always receive the event that is called. So add event dispatcher. The first is on player enter vehicle. Then add on player exit vehicle. On acceleration start. On acceleration stop. On reverse start. On reverse stop. On airborne start. On airborne stop. On drift start. On drift stop. On brake start. On brake stop. On hand brake start. On hand brake stop. On wheel bump on door open, and on door close. On ignition start, and compile. Go to on wheel bump, and we need some input. Add new parameter. The first one is wheel index, and set it to integer. And the second parameter is bump strength, and set it to float. And we compile. Save all, and go to vehicle audio controller. Click on current vehicle, and set the variable to BP VehicleBase object reference, and change variable type, and compile. And we move this bind event to the top, and disconnect this. Compile. Get current vehicle, call bind event to on player inter vehicle. Now let's create event and choose inter vehicle event, and copy this. Current vehicle, find event 2 on player exit vehicle, and create event exit vehicle. When this event on player inter vehicle call, then we call this inter vehicle event. Here is inter vehicle event. And get current vehicle, bind event to on drift start. Create event, start drifting. On drift stop. We bind event 2 and create event stop drifting. Current vehicle, and event 2 on handbrake start. Then create event start handbrake kit. Copy and bind event to on handbrake stop. Create event stop handbrake skid. Find event 2 on wheel bump. And create event tools. We don't have the event that match this signature. Go down to the suspension bump. The type is float, is not double. So click on the float again. And this one, click on the float again. It will show this error. To suspension bump. Now we have this event. And copy this. Create event. An event function is play tire bump. And current vehicle bind event to on airborne start. Create event on airborne. Next is bind event to on handbrake start. Create event play brake pedal. Copy current vehicle. Then bind event to on door open. Create event and call open vehicle door. Bind event to on door close. And create event close vehicle door. Copy event. Copy current vehicle. Bind event to on ignition start. Create event and call ignition on. And we don't need this on vehicle disable event because we don't disable this vehicle. Now we can delete this bind event and compile and delete this and this bind event. Current vehicle bind event to on acceleration start and create event. acceleration start. Okay, current vehicle bind event to on acceleration stop and create event acceleration stop next into play. Get current vehicle and bind event from on acceleration start and call create event acceleration start. Copy this and bind event from on acceleration stop. Create event acceleration stop. Compile, and we still have a lot of error because we don't have the function like get wheel slip angle in degree or get wheel mesh component. We have to go to BP VehicleBase and create those functions. Now add function. The first function is set throttle input, and the category is set input. Add input. The input is throttle. Get driver state, brake, brake, and add local variable. Variable name is brief throttle, and variable type is float. And set this throttle to previous throttle variable. Get vehicle component and set throttle input and get throttle variable set it to the throttle. Get previous throttle call nearly equal to 0 and another throttle nearly equal to 0 and copy this, paste it here and call not boolean for the throttle and previous throttle not boolean. And boolean and boolean, then create a branch. When it falls, create a branch. And if it true, call on acceleration start. Recall the event dispatcher. This is the delegate. Call on acceleration stop. Add function. The function name is set brake input, and category is set input. Add input. The input name is brake. Get vehicle movement component. Set brake input, and get brake variable. We get brake variable is from this brake input. We can connect this to this brake, or we can get the variable anywhere inside the function. Get driving state. Set member. For the struct, we use set member to set the variable, and we can expose this pin, which variable that we want to set the new value. We set it to brake, and copy this brake, make it to the variable. For the set throttle input, we forget to set the driving state. Get driving state and set member driving state. And set throttle to true. Connect this throttle to the variable and compile. Now add another function. The function name is set steering input, and category is set input. Input is steering. Get vehicle movement component and set steering input. Get steering. And get driving state. Set member in ST driving state. And enable the steering. Copy the steering. Add another function. The function name is set handbrake input. Category is set input, and add input. The input name is new handbrake. And variable type is Boolean. And create a branch. Get vehicle component. Set handbrake input. Get new handbrake variable. If it's true, we set this and get driving state. set member in driving state. B handbrake on and use this new handbrake. Then call on handbrake start. Call delegate and copy this. If it falls, we call on handbrake stop. Now compile and go to event graph, and we use this function instead of this, because inside this function we have the call event. Press Ctrl on this and connect it to throttle. Delete. Set brake input and this brake, and set handbrake input, new handbrake. Set steering input and steering. Can compile this. Now add function. The function name is get wheel mesh component, and set it to pure function. Add input wheel index and set it to integer. Add output. The output is wheel mesh component. The variable type is mesh component. Object reference. And we can call print string. The print string is called base implementation of get wheel mesh component. Sorry for the wheel mesh component output. We change it to static mesh. And this one, object reference, and compile. All this function I translate it from C++ from the city sample project. And let's add another function. Is vehicle drifting. The output is drifting and Boolean. And set it to pure. And get B is drifting Boolean, connect it to the output. Add function. Name it get wheel flip angle in degree. And the input is wheel index. Integer. get vehicle movement component has to chaos wheel vehicle movement component. Then add local variable. The variable name is movement component. And variable type is chaos vehicle movement component. And set it to this movement component. Get num wheels and get wheel index variable less than the wheel number, and create a branch called return and add output. The output name is return value and type is float. Then get movement component. We need to compile this first. Copy this wheel index because this variable movement component we have the wrong variable. We have to set it to chaos wheel vehicle movement component, not chaos vehicle. Change variable type and compile. Get wheel state from the wheel index. Then break the status and return the slip angle and convert it from radian to degree. Return this slip angle if it's true. And copy this return. If it false, we return 0 angle, and also when it casts false. Compile and save all. We close all these functions. And for the get wheel flip angle in degree, click on this and set it to pure function. Now duplicate this function, get wheel flip angle in degree, Ctrl D, and get normalize suspension length. Set it to this pure function, and everything is the same, but we return the normalized suspension length instead of the slip angle. Delete this. And compile. Add new function. The function name is check all wheels on ground. Get vehicle movement component has to chaos wheel vehicle movement component. and go to local variable, add variable, name it VMC for vehicle movement component, and set this VMC. Then call for loop from the flow control, and the last index is 3 because we have 4 wheel, and the first index is 0. Add local variable. The variable name is wheel index, and variable type is integer. Then set this wheel index to the index and create a branch. We get VMC, get wheel state, and get wheel index next to the wheel index. Then break wheel status. In contrast, call not boolean, connect it to the break condition. And for the return output, name this to return value and set it to boolean. And if it's true, we call return node. And when it completes, we call return node, but we return the value is true. Also when it casts false, and we delete this return node here. We can set this to pure function. Duplicate text or wheel on ground function. Press Ctrl D and rename it to check no wheels on ground. When we check no wheel on ground, we from the wheel status. In contrast, we do not call this not boolean. So if it's true, return false, and if it's false for all of the wheel, we return true. Then add new function. The function name is on literal break start. Get is literal breaking. Create a branch. If it's true, we set is literally breaking to true. Then call on break start. Add new function. The name is on literal reverse start. Get is reversing and not boolean. Create a branch. If it's true, we set is reversing to true. Then call on reverse start and add new function. The name is on literal reverse stop. Get is reversing and create a branch. If it's true, we set is reversing to false. Call on reverse stop. Add new function. Name is on literal break stop. And you can close all these functions. Open literal break start and copy this and paste it inside this on literal break stop. Control V. When it falls, we set it to is literally breaking to true and call on break stop. Now compile, save, add new function. Name is update vehicle drifting state, and the category is update state. Then get vehicle movement component has to chaos via vehicle movement component and add the local variable. For the local variable, we can only call inside this function. And name is movement component. And variable type is chaos via vehicle movement component. And set this chaos wheel to movement component. Get is drifting, and then set add another variable, local variable. Name is brew is drifting. The variable type is boolean. Set to this previous is drifting. Get via slip angle in degree and greater or equal get rear via slip angle drifting mean threshold and copy this. The wheel index is 2 and the other one is 3 and call or boolean. Get driving state, break the state, forward speed greater or equal, and get drifting speed min threshold. And call and boolean. Then set to B is drifting. Get is drifting not equal to previous is drifting, and create a branch. If it's true, we call on drift start, and if it false, we call on drift stop. And compile. Add new function. Name is update via suspension state. And add input. The input name is data type and variable is float. And get via suspension states array length and call for loop. And this length we use as the last index. Add local variable. Variable name is index. And variable type is integer. And set it to the index. Then call sequence. And the first sequence we get via suspension states and get the suspension state using the index. Then add local variable. The name is suspension state. Variable type st via suspension state. And set this to the suspension state. Get index. Get normalized suspension length. And then add new local variable. The variable name is normalized suspension length. And set it to float. Set it to this normalized suspension length. Then add new variable. Name is suspension diff. and set it. Get suspension state, break the wheel suspension state, and get the length of the previous normalized and subtract it with the normalized suspension length next to suspension diff. And for the next sequence, we get suspension diff greater normalized suspension diff threshold. Then create a branch. Get suspension diff, subtract it with normalized suspension length and add new local variable. Name is bump string. And set it to bump string when it's true. Get the index and then call on wheel bump delegate and connect this wheel index to and bump string to this string. I type this wheel index wrong, so go to on wheel bump and change this to wheel index. Let's compile. So we need to call this again because we made some change to the variable. Go to BP wheel and this one is working. Add another pin to the sequence. Get normalized suspension length, and if it equal to 0, create a if it equal to 1, create a branch and connect this to the branch. Then get suspension state and set member. When it's true, we set this time span in a ball. Copy this suspension state and break it. Get this time span at full length. Add it with the data time from the input. Get delta time variable and it to time span at full length. And if it falls, we create a branch. Copy this suspension state and break For the length, we for to 1 and connect it to the condition and copy the suspension state. Set member in st via suspension state and set this time span at full length to 0 and add another sequence pin. Get suspension state, set member, connect it to the sequence and expose this previous and expose this time span and expose this previous normalized suspension length. Get normalized suspension length, connect it to this previous normalized suspension length. Now compile. Now add another function and name this to update driving state and set this to the update state category and update driving state to update state category. Create a sequence. Get vehicle movement component and cast to chaos via vehicle movement component. Go to local variable, add local variable, name is VMC. And this variable type is via chaos via vehicle movement component. And set it to VMC. Get driving state, set member, and the members are automatic, forward speed, RPM, and gear. We have a little bit error. This gear should be integer. So go to audio, struct, and st driving, and set the gear to integer and save. And we compile this. So it's set the gear and get VMC, get use auto gear, set it to automatic, VMC, get forward speed, set it to forward speed of the driving state, and VMC, get engine rotation speed, set it to the RPM, and VMC, get current gear, set it to the gear, and then get VMC is path, set to the variable b is path. And for the sequence, we call get each part and create a branch. Name it to the sequence. And if it's true, we call on literal break stop function. If it's false, create a branch and get driving state, break this st driving state, and the forward speed we call nearly equal to 0 and not boolean. It to the branch, and when it's true, we copy this driving state and this forward speed greater than 0 and create a branch when it's true. Copy this driving state, and for this break we call nearly equal load to 0 and copy this and change to throttle, not boolean. For both of it, then create a branch, and this one create a branch too, and connect when it's true to the branch, and when it false, connect it to the branch. When it's true, call on literal break start, and when it false, on literal break stop. And this one on literal break start and on literal break stop. And when this forward speed not equal to 0 is false, we create another branch and copy this drive state. The throttle nearly equal to 0 and the brake nearly equal to 0 and call not boolean both of it and boolean. Need two condition. If it's true, call on literal break start, and if it false, on literal break stop. Add another pin for the sequence, and next we get each part variable or boolean and add pin to the or. Copy this driving state, speed forward and nearly equal to 0. And connect to all. Copy this state. Forward speed greater than 0. Connect to all. Then create a branch from this. And connect to the sequence. When it's true, call on literal reverse stop. And if it false, create a branch. Copy this driving state. The forward speed less than 0. And copy this driving state. The brake nearly equal to 0. Not Boolean. And copy this. The throttle nearly equal to 0. And connect to N Boolean for these three conditions. Connect this condition to the branch. If it's true, we call on literal reverse start. Next, we add another pin to the sequence. Get driving state. Set member of the state. And enable all wheel on ground. And call check all wheels on ground function. I told this all wheel on ground. And connect to this sequence. And copy this. Add new local variable. The variable name is b preview no wheels on ground. And variable type is Boolean. Then set to preview no wheels on ground. This on should be capital letter. Compile. That is no wheel on ground. Get call check no wheels on ground function. Get driving state. Set member. And set to no wheel on ground. Then add another sequence pin. Copy this driving state. All wheel on ground. Create a branch. And connect to that sequence. And set to it's okay to fire airborne even if it's true. Set it to true. Compile. Forget another sequence. Add pin and use this as the quick sequence. Move it down. Get it's okay to fire airborne event. Call and boolean and get the proof no wheel on ground not equal. Get driving state, then break the driving state. No wheel on ground to this boolean and connect to end. Create a branch and connect it to the sequence, the fourth sequence. Get driving state, break the driving state, and no wheel on ground. Create a branch, and when it's true, we call on airborne start, and when it falls, we call on airborne stop. Compile. Go to event graph on event tick. Call update driving state. Then call update vehicle drifting state. Get is possessed by player. Create a branch. If it's true, we get var delta second and call update wheels suspension state. Next this data time. Now save all. And we need to go to this BP car interaction. Edit BP car interaction component. Go to event graph. And after we process this from the inter car, get vehicle, then call on player inter vehicle to this, and another one is called on ignition start. Let's comment on this. Set another color, red. Copy. And in this inter-car teleport event, after we process, we call this player inter vehicle and call on ignition start delegate. For the exit, this exit car teleport. After we process the character, get vehicle, call on player exit vehicle. compile, comment on this, set the red color. We call this event when we enter and when we exit. Close. Go to vehicle audio controller and go to the error so we can fix it. This we get wheel flip angle in degrees and the wheel index is 0. Compile another one, get wheel mesh component and connect this to wheel index and we get the wheel mesh component. This is the static mesh component, so go back to VehicleBase and find the function, set it to static mesh component object reference output. Open and we can see this is the static mesh component. Compile back to this audio controller, connect it to wheel mesh component and delete this. Compile. And this we get wheel mesh component from the wheel index, set it to the wheel component. Compile and get parent actor. We don't have the VP VehicleBase variable. We need to cast to VP VehicleBase and set it to this VehicleBase to the current vehicle. Compile and this one connect it to vehicle movement component. This we don't have the vehicle type variable, so delete this and set it to default. And we get the driving state. It get error because this is from the different struct. So we have to call it again and split the struct pin. Connect to steering, and this one is no wheel on ground, and delete this. Call is vehicle drifting function to not out. And next we get forward speed from the vehicle movement component and greater than 0. And we get driving state again. Play this. The throttle, connect to throttle and connect to this V for the throttle and the brake to this, steering to absolute, no wheel on ground to pick A, delete this, get drive state, and call is vehicle drifting and pick the float, and we get actor rotation. And in this one, get driving state, split to throttle, brake, and forward speed. Delete this. And the last one, we don't have the on vehicle backfire, so delete this. All delegate and close all of this. Go to event graph and we compile. Now we don't have any error. Let's play test. Go inside vehicle and we have some error here. Let's go to set suspension state and get a copy, not a reference, and set it to suspension state and compile. Save. And inside this update vehicle drifting state, we have the sound of the drifting because we have an error. So copy is drifting and create a branch. And when it true, connect to this. When it true, we call on drift start. And when it false, we call on drift stop. And for this, is not equal to previous drifting. If it's true, we call this delegate. Compile and save. Let's play test and enter the vehicle. Now when we turn, we have the sound of the drifting vehicle. And the sound is working. To debug this, we have to go to vehicle audio controller and add new function. The function name is print driving state. Get current vehicle target driving state and break Destruct and append string like this, throttle to the append and name this is throttle. Copy, name it to brake, steering, and brake on. Forward speed. RPM. Gear. automatic, all wheels on ground. No wheels on ground. Move it next to each other. Then connect this to B. Brake to brake, steering, and brake on is forward, speed, RPM, gear, automatic, or wheel on ground, no wheel on ground. Then create a sequence, print string, and set the duration to 0. Connect it to this. Copy, paste. And connect to this string. And the sequence, we add it. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 variables. So add it to 9. And connect the 0 to the last one, because the first that is print, it stay at the bottom, so we print the last one first. And this one we call return node. Go to event graph, and in the event tick, call this print driving state. Let's save all and close this. Play test. Go inside this vehicle, and you can see the throttle when we move forward it's 1, and when we don't push forward it's 0, and when we press S, the brake is 1, when we release it's 0. Steering, steer left is -1 and steer right is 1. On handbrake, when we press space it's true, and when we release it's false. And you can see the speed forward and RPM, the gear. When you move faster, it change the gear to 2, and when we press brake, the gear is -1. You can see all wheel on the ground, and when the car is flying, all wheel fall on the ground is false, and no wheel on ground is true. it's worked correctly. So go to event tick and disconnect this. We use this print driving state to debug it. Thank you very much for all your support on Patreon. I truly appreciate it. It really means a lot to me. If you like this tutorial, please hit like and please subscribe to my YouTube channel and see you in the next tutorial.